Lesson 27. Looking back at the operations of power series. Now, in terms of this particular video, okay, we are actually going to talk about the operations on power series. So, if I've got these two functions equal to these two particular power series, so f of x is equal to this series and g of x is equal to this series, okay, and I look at f of k times x, so k being some number multiplied by x, this function, okay, this function is really going to be equal to a sub n, k to the power of n, x to the power of n. Now, why does this make sense? Well, remember, when I plug kx in for my new x in my function, in here it's going to be kx all to the power of n. Well, I can distribute the powers over multiplication. That's how I get to this. Likewise, f of x to the power of capital N is going to be the same thing as x to the power of n times capital N. Well, why is that? Well, remember, when I plug n x to the capital N inside here, it's power to the power. Power to the power, I multiply the powers, so I get this. Okay. Lastly, if I take two functions and add or subtract them from each other, the summations on the inside will be adding or subtracting each other. Now, in your notes, there's a slight typo. Make sure you add this x to the n piece. Otherwise, we don't have the x to the n that these two have, and they're supposed to. So, with that being stated, let's take a look at example number 5. It says, find a power series centered at 0 for 3x to the negative 1 divided by x squared minus 1. So I'm going to rewrite that. F of x is equal to 3x minus 1 divided by x squared minus 1. Now, when playing with this thing, what I'm going to have to do is very carefully change this, because I don't know this series, the function that this series is, or sorry, the series that this function is supposed to go to. I don't know that. I do know, the only one that I know in this unit is the geometric one. So I want this thing to be in some way compared to 1 over 1 minus x. That's what I want it to be compared to, okay? Well, for me to get that, this bottom piece, doesn't that factor 3x minus 1 divided by x minus 1, x plus 1? Wasn't there something with integrals that we did to make this like this in some way? I feel like it was something with x. I'm gonna go ahead and write the plus 1 first and the x minus 1 second. And couldn't I put a plus sign between them somehow, and maybe an a and a b here? Wasn't this partial fraction? Okay, decomp. And we can use this method here as well. Okay, and so we will do so. Now, I'm not actually going to show it. We're just going to go ahead and go through all the work, letting this thing equal to this thing, manipulating both sides, get a plus b in some way, blah, 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 equals to some numbers. A is going to be equal to, in this case, a value of 2, and b is going to be equal to a value of 1. Okay? Now, we'll very carefully plug in 2 and plug in 1. Okay? So, this function is equal to 2 over x plus 1 plus 1 over x minus 1. Now remember, this is really close to what I'm looking for, this thing right here. So let me manipulate this thing so it looks like this, okay? So this is equal to 2 divided by 1 plus x plus 1 over a negative 1 plus x. Again, I'm writing it so that the x is second and the 1 is first. Now for this one to be something over 1 minus x, I need to change this to be 2 over 1 minus negative, because then it's plus x. So that's the first one, okay? And the thing that gets plugged into the series is negative x. This is plus. On this side, all I really have to do is factor out a negative. So I'm going to factor out that negative and make this 1 minus x on the bottom. Okay, again, changing the sign to a positive, changing the sign to negative. So when that happens, now I can say that, hey, this is summation, okay, of n equals 0 to infinity of 2 times negative x to the power of n. Plus, this one over here will be a summation of n equals 0 to infinity of a negative 1 times x to the power of n. Again, the rule that I know is this thing right here is equal to the summation as n equals 0 to infinity of x to the power of n. That's all I know. Okay, so these things are going to be the same, except for my x here is negative x, and my x here is actually x, and the constants in front, 2 and negative 1, are just being multiplied by the series. Now, That's what these two functions are in terms of the series. I want to write this as one series. So the summation is n equals 0 to infinity. They're both the same sum, so I can just combine them together. I'm going to have a 2 times negative 1 to the power of n, x to the power of n. Yes? By tearing this apart, making it negative 1 to the power of n, and then x to the power of n. This is plus a negative 1 times x to the power of n. Well, if this is the summation I'm playing with, can I make this n equals 0 to infinity of, and factor out an x to the n from both of those? This is 2 negative 1 to the power of n minus 1, all multiplied by x to the n. This is the series that I'm playing with. Now here's the real kicker in terms of a question. Where does this thing converge? What's its radius? And what is its interval? Well, it's really actually quite convenient, because didn't this one right here have an interval and a radius of 1? And wouldn't this one have the same thing, a radius of 1 and an interval? Technically, it would negate it, okay? But the absolute value of negative 1 or negative x doesn't change anything. So that would still be from 1 to 1, okay? Both of these intervals would be 1 to 1. The radius would both be 1 to 1. Therefore, they match up, and my radius would be equal to 1. And my interval would be from negative 1 to 1, okay? If we know the interval of convergence on the original series, on the original function, then we know the convergence on the operations of all of those, okay? All of those series will converge to those functions based on the same interval that the function that we played with originally, okay? So that covers example number 5. That right there is example number 5. Let's see if I have time to do example number 6. It says, find a power series for f of x equals the natural log of x centered at 1. F of x equals to the natural log of x. Okay. Now, this one in particular requires some previous knowledge. Okay. And previous knowledge in a sense that we should have done this in section 9.8. We didn't do it in 9.8 for a particular reason. I want to do it at centered at 1. Okay. What we actually have to do here is think creatively. Okay. Now let's recall a specific example. Okay. Well, the specific example that we're going to recall is number 3. Okay. Number 3 says I have f of x, and that's equal to 1 over x. And it's equal to the summation, okay, as n equals 0 to infinity of a negative 1 to the power of n, x minus 1 to the power of n. Okay, now I might have done some simplifications on this in terms of from my example 3 to this actual problem, but this is the same thing as what I had in example 3. Now, question I'm going to ask you is, how does 1 over x and the natural log of x compare? Again, how does 1 over x and the natural log of x compare? What would relate these two functions? And I hope the first thing that comes to mind is that you know that when I integrate this, I get to this. So f prime of x, I'm going to go ahead and change this. I'm going to call it g of x for a moment. I know f prime of x is going to be equal to 1 over x. Yes? If that's true, then that means my derivative series is going to be equal to this. Then my question really devolves into, do I want this series? No, I want this series. How would I go backwards from this one? Well, I'd have to integrate this, right? That's going to give me f of x, which means that I can integrate this. That would give me the natural log of x, which means that I should, yeah, here it is, integrate this thing. Okay, so I want to integrate this series. Now, if you're having difficulty grasping that concept, write the series out. Okay, it's not going to hurt you, but there's an easier way. This is the function that I'm really playing with right here. Okay, this negative 1 is to the power of n. It's just some constant that I end up multiplying after I plug in n. This is really what we're changing. Now, what is it that I do when I have x to the power of a number? A number. N is going to be a number for every single one of the terms that I pick. So, as n goes to infinity, we're getting more and more of these terms, but x minus 1 to the power of n, what is the integral of that. What do I do when I have x to the power of something? Well, I increase the power, and I divide by that power. So integrating this whole series will actually give me the series as n equals 0 to infinity of the negative 1 to the power of n, because that's some constant multiplied by the derivative of this. Or sorry, the integral of this. What's the integral of this piece right here? X minus 1 to the power of, increase the power, divide by the power. That, right there, would be considered, okay, our power series for natural log of x. Okay? If you're not confident with that, go ahead, like I said, write out this series. Take the integral of each individual term, and notice that it follows this pattern every single time. Okay? So we will come back to integrals and derivatives in this particular section. Okay? It's just for right now, that's where we wanted to start. Okay? That's where we wanted to start, was the natural log function, because it was something we knew.